The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to actually wrap up the chapter. We're going to take a look at section objective 1F, which is order of operations. Your homework assignment tonight is both the order of operations section and the chapter review. Now, I know that's a lot to do in one night, but here's the deal. Tomorrow in class, we're going to review. If you wait until tomorrow night to do the review, that's fine, except if you have any questions, you won't have any chance for feedback because on test day, there is no class meeting. There's no Zoom meeting, okay, on test day. So the idea is to do section objective 1F tonight and the chapter review. Now, a couple of things. I thought I would hear from people if they needed an extension on 1D. I only heard from one person, but I went ahead and extended 1D through tomorrow if you didn't finish it. But I have a warning for you. What some of you are doing is a bad thing. You are waiting until the day an assignment is due, not the day that it's assigned, but the day that it's due, and then working on it late into the evening and not finishing it, okay? Let me repeat again what your strategy should be. On the day it's assigned, that's the first column on the syllabus down at the bottom. When I present the material, you should try to complete the entire assignment. If you're not able to complete it because you have questions, you can email me, and then the next day during the Zoom meeting like this, I will do those questions for you. You can then finish it up and have the assignment done because you've got to start a new assignment. But waiting till the day it's due to start it, not a good strategy. Okay, anyway, enough nagging and scolding you and all that. With that, we're going to go on. So are there any questions before we go on? Anybody, anything? All right. So does the cat know how to multiply and divide? Yes, hopefully. Okay, just check it. All right. Get back there. Hang on here. All right. Today, we're going to talk about this. It is often referred to as Pemdas, or please excuse my dear Aunt Sally. How many of you have seen this before? Anybody? Okay. This was a trick question. I hope you've never seen this before because it's wrong. You're going, what do you mean it's wrong? Well, let me tell you what it's supposed to be. It's supposed to be that. Hopefully that's what you actually saw. What's the difference? Okay. This is the correct way. What it says is this is order of operations that you do things when simplifying an expression. You do parentheses first, which could also include other grouping symbols, brackets, absolute value bars, yada, 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 but basically grouping symbols, parentheses, then exponents, then multiplication or division, whichever comes first from left to right, and then addition or subtraction, whichever comes first from left to right. So you could also write it this way, I suppose. Okay. Pedmasa just doesn't sound quite as nice as PEMDAS, does it? But the point is, this is not correct. It's not multiplication and then division. Okay. Hopefully you were taught this and maybe you've just forgotten, since then. But all right. So this is the order in which we will be doing things. All right. So now let's take a look at a bunch of examples. Give me just a second here to get things moved around. And here we go. All right. So we've got the following problem. 12 minus 2 times 4. So the question is, do we subtract first or multiply first? Well, if we go back to our order of operations, multiplication or division comes before addition or subtraction. So this would be 12 minus 8, doing the multiplication first. And then finally, the subtraction, 12 minus 8 is 4. Any questions about that problem? All right, let's take a look at this problem. 12 minus 2 times 4. Notice it looks a lot like the first example. That's intentional. However, there's something slightly different. There's a grouping symbol, parentheses. So back to our order of operations, we would do parentheses first. So that means we do what's inside the parentheses. 12 minus 2 is 10. Then we've got 10 times 4, multiplication is 40. So we started with the same numbers, but because of that grouping symbol's location, it completely changes the outcome. Order of operation is not whatever looks good or from left to right. It's a very specific order that you have to do things, okay? Any question about these two examples? All righty, let's see here. How about this one? 18 plus 0 times 7. Again, we would do what's in parentheses first. What's 18 plus 0? Well, it's just 18. 18 times 7, let's see, that's a big number. 18 times 7, 7 times 8 is 56. Carry the 5, 7, 1, 26. Okay. What about this problem? 18 plus 0 times 7. Well, now there's no grouping symbol. So now we would do this multiplication first. 0 times anything is 0. So 0 times 7 would be 0. And anything plus 0 is just the original anything. So again, the grouping symbol, the parentheses changes everything. We okay so far? Any questions, concerns, comments? Okay. How about this one? 15 divided by 5 minus 2. So we've got division and subtraction. We do division before subtraction. What's 15 divided by 5? It's 3. And then 3 minus 2 is 1. So again, division before subtraction. Let's take a look at this problem. 15 divided by the quantity 5 minus 2. We've got division, subtraction, but we've got a grouping symbol. We do what's inside the grouping symbol first. 5 minus 2 is what? 3. 15 divided by 3 is 5. So again, the grouping symbol changes everything. Doing okay still? Everybody? Okay. All right, let's see here. How about this problem? 60 divided by the quantity 10 plus 5. We would do what's inside the parentheses first. 10 plus 5 is 15. Then we would do the division. 60 divided by 15 is 4. Questions there? Okay. 60 divided by 10 plus 5. Without the grouping symbol, we would do division before addition. 60 divided by 10 is 6. 6 plus 5 is 11. Any questions on that example? Okay. Let's see here. Let's take a look at this one. 18 divided by 2 times 3. Now, there's no grouping symbol. There's a division symbol and a multiplication symbol. What's the rule for that? Well, let's go back here. Multiplication or division, which we do whichever comes first from left to right. So I'm going to do the division first because it comes before the multiplication. 18 divided by 2 is 9. 9 times 3 is 27. Okay. Let's take a look at this problem. 18 divided by the quantity 2 times 3. Question, Rebecca? Yoo-hoo, Rebecca.
No.
Okay, thank you. All right, we return to our regular programming after that exciting advertisement for whatever it was. Okay, now, same numbers, same operations, but there's a grouping symbol. Are you getting my idea here? The grouping symbol changes everything. So we do what's inside the grouping symbol first. 2 times 3 is 6, and then we do 18 divided by 6 is 3. All righty. Let's take a look at this one. 3 times 15 divided by 5. We would do inside the grouping symbol first. 3 times, let's see, 15 divided by 5 is 3. 3 times 3 is 9. Or what about this one? 3 times 15 divided by 5. No grouping symbol here. Multiplication or division, whichever comes first from left to right. 3 times 15 is 45. 45 divided by 5 is 9. Interesting. We got the same answer. Different order, though, for doing things. All right, let's see here. How about this one? 7 plus 5 squared. So we have addition and an exponent. Well, let's go back up here to our order of operations. Let's see here. What a mess. Maybe I can get rid of all these extra scribbles. There we go. Okay. So we had addition and an exponent. Exponent would come before addition, right? Okay. So this is 7 plus, what's 5 squared? That's 5 times 5 or 25. And 25 plus 7 is 32. That's actually, that's not 32. What am I doing? I'm multiplying. Hang on. Tilt, do over, redo, reboot. 25 plus 7 is what? That's 12. It's 32. I was talking addition and braining multiplication. I don't know. Anyway, sorry about that. Okay. And then let's take a look at this one. 7 plus 5 inside a grouping symbol, and then the whole thing squared. So the parentheses before exponents, 7 plus 5 is 12. 12 squared is 144. Any questions? Still doing okay? All right. How about, let's see here. This one. Parentheses, 8 divided by 2, close parentheses, cubed. So we've got a grouping symbol, we've got a division symbol, we've got exponent. You would do the grouping symbol first. So we're going to go inside the parentheses. 8 divided by 2 is 4. So then we're going to get 4 cubed, which is 4 times 4 times 4. 3 factors of 4. 4 times 4 is 16. And 16 times 4 is 64. Okay. What about this problem? 8 divided by 2 cubed. What would you do first here? The division or the exponent? You do the exponent first. 2 cubed is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 8 divided by 8 is 1. Okay. What about this problem? 3 squared minus 3 over 6 plus 0. All right. Now, a fraction bar, among other things, is a grouping symbol. It separates the numerator from the denominator. So it falls under the category of grouping symbols, which we just use the P for parentheses, but that includes other grouping symbols as well. So I'm going to deal with the numerator first. I've got an exponent and subtraction. I would do the exponent first. 3 squared is 9. Okay. And 9 minus 3 is 6. So simplifying the numerator first, it breaks down to just 6. Now I will move downstairs to the denominator. 6 plus 0 is 6. Can't do anything more with it yet, so I carry it on over here. Now that I've simplified the numerator and the denominator, divide 6 divided by 6 is 1. Any questions there? All right, let's take a look at this one. 5 squared plus 6 divided by the quantity 7 minus 6 cubed. So again, the fraction bar is a grouping symbol. Going above, we would do the exponent before addition. 5 squared, 5 times 5 is 25. Then we would do the addition. 25 plus 6 is 31. In the denominator, we have a grouping symbol parentheses. So we do that first. 7 minus 6 is 1. Then we apply the exponent. 1 cubed is 1 times 1 times 1, which is 1. And finally, 31 divided by 1 is just 31. Okay. Doing all right? Give me just a second here. I want to look at something. Yeah, okay. How about this one? Don't panic. It's going to look big and nasty, but it's not too bad. Don't panic. Okay, we're going to start in the numerator. We've got the grouping symbols within the numerator first. What is 5 minus 2? That would be 3. So I've got 3 squared, right? I did the inside, still the result is squared. Then plus, okay, plus 11 minus 7 is 4, but that's squared. Still working in the numerator. 3 squared, 3 times 3 is 9, plus 4 squared, 4 times 4 is 16. Still working in the numerator. 9 plus 16 is 25, okay? So I did all that simplifying the numerator. Isn't this fun? Aren't you having a good time? Oh, okay. I'm all right. Thank you. Thank you. That may have been insincere, but I'll take it anyway. Okay. So now to the denominator. We've got exponents and subtraction. We do the exponents first. 3 squared. Oops. 3 squared. 3 times 3 is 9. minus 2 squared, which is 4. 9 minus 4 is 5. And finally, 25 divided by 5 equals 5. Final answer. Okay. Nobody died, did they? Everybody still breathing? We good? Okay. All right. Let's take a look at, let's see. Let's do this one. 5 squared plus 4 squared times 3 squared. We've got exponents, we've got addition, we've got multiplication. Exponents are first. 5 squared is 25 plus 4 squared is 16 times 3 squared is 9. Then we do multiplication before addition. 25 plus, well, let's see, 16 times 9. 6 times 9 is 54, carry the 5. 1 times 9 is 9, plus 15, or plus 5 is 14. So I get that. 144 plus 25, let's see, that's a 9, 6, 169, final answer. Okay. All right, now we're going to continue to look at some problems involving order of operations. Only now we're going to end up with some negative numbers to deal with as well. All right, so let's say we've got this problem. Negative 27 minus 28 divided by 4. All right, so we've got a negative 27, we've got a subtraction sign and a division sign. What would we do first? The division. So we're going to deal with this first. So that's negative 27 minus, well, what's 28 divided by 4? That should be 7. Okay. Now I've got negative 27 minus 7. And if you can look at it and go, oh, that's negative 34, you write the answer and walk away with a big smile on your face. Okay. But if you struggle with that idea, we're going to go back to what we looked at earlier. We're going to change subtraction into addition of the opposite. Now, I don't change the negative sign. That's not a subtraction sign. That's a negative 27. I change subtraction to addition of the opposite. All right. Now I'm adding two numbers with the same sign. So you add their absolute values and attach the common sign. Okay. So we're going back to earlier in the objective that was integers, adding and subtracting integers. Okay. Not to mention multiplying and dividing. All right. Any questions there? Okay. What about this? Negative 3 squared. This is an exponential expression. The base is negative 3. It's everything inside the parentheses to which the exponent is attached. The exponent is a 2. So the way to interpret this is that I have 2 factors of negative 3. Negative times negative is positive. So this would be positive 9. Okay. This one, usually everybody gets right. It's the second one that gives people problems. Now, in the first example, the negative sign was inside the parentheses, so it was part of the base. In the second example, here, let's label these example 1 and example 2. In the second example, the negative sign is not part of the base. It is not captured inside the parentheses. So this is the same thing as saying -1 times 3 squared. So we do the exponent before the negative. So that's going to be what? 3 squared would be 9, and -1 times 9 is -9. So basically this equals 9, but this equals -9. Here, the negative sign is included in the squaring. Here, it is afterwards, after the squaring. Okay. Now, if that still got you stunned like a deer with the headlights at night, wanting to run off into the bushes, take a look at this. What if I had, let's see, where did it go? If I had this, 4 squared minus 3 squared, okay? Wouldn't that be 16 minus 9? Now, I'm going to stop there with this problem. I'd go further and get a 7, but you see how I got from the first step to there? Is everybody okay with that? All right, what if I did this? You see what I'm getting at? So the answer is -9, going back to what we did here. Oops. Okay, that's a tricky one. If we need to revisit that, let me know. Okay, let's see here. How about this one? -2 cubed minus 5 squared. Okay. So the first exponent, the negative sign is not included. It's kind of like as if though it were written like that. Okay. But we don't bother to put the parentheses there, but it's implied. In other words, the negative sign is not part of the base. So this is a -1 times 2 times 2 times 2. Well, 2 times 2 is 4 times 2 is 8. So basically this is -8. All right. Minus 5 squared, which is 5 times 5, which is 25. Okay. So in neither of these is the negative sign included as part of the base. Well, now -8 minus 25 becomes -8 plus -25. Subtracting a number is like adding its opposite. We're adding two numbers with the same sign. So we're going to attach the common sign. Final answer, -33. Okay. Now, let's take a look at this one. -4, the quantity squared minus 6 squared. So here, the negative sign is inside the parentheses. So this is -4 times -4, which is positive 16, because negative times negative is positive. And then minus 6 times 6 is what? 36. Okay. Let's see. I'm subtracting a larger number from a smaller number. I'm going to change that to addition of the opposite. Now, if you can take 16 minus 36 and look at it and go, oh, that's -20, great. I'm happy for you. You do it. But if you struggle with it, go through these steps, change subtraction to addition of the opposite. Adding two numbers with opposite signs, we subtract the smaller absolute value from the larger. But then we attach the sign of the number that had the largest absolute value. So final answer, -20. Or think of it this way. You get two letters in the mail. You get a check for $16. Woo, your tax return. Woo, exciting. Oh, you get a bill for $36. Well, you cash your tax return check to pay your bill, but you're still $20 short. They're coming to get you. Oh, well. All right, just when they come to the door, hold up a math book. That'll scare them away. All right, we okay with this? Let's see here. Doing, we got 2 minutes. Let's take a look at, let's do this one. Let's try that again. We've got the absolute value of 5 minus 9 times the absolute value of 9 minus 5. Wow, we haven't seen anything like this before. Absolute value bars are a grouping symbol. So like parentheses, we would do what's inside first, okay? So 5 minus 9. Let's see, 5 minus 9 is like 5 plus negative 9, which is going to be negative 4. So 5 minus 9 is negative 4, still inside the grouping symbol. Okay? But if we take the absolute value of negative 4, what do we get? We get a positive 4. Okay? Inside the second absolute value, 9 minus 5 is 4. So inside it simplifies to 4. What's the absolute value of 4? 4. And now finally, 4 times 4 is 16. Okay, let's see here.
Did the absolute value come after the parentheses?
No. Okay, let's take a look at that. You kind of work your way from the inside out. Let's say I had this. Okay, in that case, I would do the parentheses first, working my way to the outside. Okay, now let's say I had this. In that case, I would do the absolute value first, working my way from the inside out. But what about this case? What if I had, let's see here, that? You would do the grouping symbols from left to right. So in this case, you would do the parentheses and then the absolute value, et cetera, et cetera. Excellent question, though. Yeah, so when you've got some things like this, start on the inside and work your way outside. Okay. All right, let's see here. I now want to go to just one. -7 plus parentheses -3 plus -12 divided by 4, the whole thing squared. Is this one of those problems where it should have a warning, don't attempt this at home or something like that, or do not take medication while doing this? All right. So where am I going to start? Inside the parentheses. Inside the parentheses, where am I going to start? The addition or the division? The division. So the first thing I'm going to deal with is that right there. Okay, everybody clear why that's the case? So now, let's see, -7 plus -3 plus, oh, what is -12 divided by +4? It would be -3. Okay, so all I did was the division. I'm still working inside the parentheses. Well, what have I got there? I've got addition. -3 plus -3 is -6, but that's squared. Okay, because the square keeps moving down. So now I've done everything I can do inside the parentheses. I've got addition and an exponent. I would do the exponent first. So -7 plus, well, let's see, -6, the quantity squared is -6 times negative 6. The negative sign is part of the base, so that's going to be a positive 36. Adding two numbers with different signs, subtract the smaller absolute value from the larger, attach the sign of the larger absolute value, which was positive. So final answer, positive 29. All righty. Let's see here. Okay. How about this one? 3x minus 7y, where x equals negative 5 and y equals negative 6. Now, before you panic because letters have shown up, we're not going to be writing paragraphs. We're going to make a substitution, actually a couple of them. We have this algebraic expression, meaning it has at least one variable. It has two variables, x and y. But we're told the numerical value of each variable. So we're going to replace x with negative 5, and we're going to replace y with negative 6. When we replace a variable with its numerical value, the safest way to go is to put parentheses around the substitution. Okay? By doing that, I keep the original operations intact, because right here, 3x, that's 3 times x. 7y, that's 7 times y. So now instead of having 3 times x, I've got 3 times its replacement of x, negative 5. And then 7 times y, 7 times y's replacement, negative 6. Okay. So now I've got multiplication. I always leave I always say multiplication. That's not a good thing. All right. Multiplication before subtraction. 3 times negative 5 would be negative 15 minus 7 times negative 6 would be negative 42. Okay. So now I've got negative 15 minus negative 42. I'm going to change subtraction to addition of the opposite, which gives me negative 15 plus 42. Subtracting a negative is like adding a positive. Adding two numbers with different signs, subtract the smaller absolute value from the larger, borrow and carry. Attach the sign of the number with the largest absolute value, it's positive, so final answer, 27. Now, I want to show you something. If it confuses you, you're not ready for it, that's great. Don't worry about it. But if you're like, oh yeah, that makes sense, then do this. Let's go from the step where we have 3 times negative 5 minus 7 times negative 6. Okay. 3 times negative 5 is negative 15, right? What I want to do, in fact, let's go back here before we even do that. I have a product, 3 times negative 5, minus a product of 7 times negative 6, right? So this is like one big subtraction problem. What if I did this? What if my first move was to change subtraction into addition of the opposite? Okay. So now I've got 3 times negative 5 is negative 15 plus Negative 7 times negative 6 is positive 42. And which would go on to be 27. Did you follow what I did there? I'm getting a lot of this. Let me go even further with it. So then ultimately what you could do is this. You could say, well, that's negative 15 and that's going to be plus 42 because you're thinking of that as plus negative 7 times negative 6. Now, why do that? Why burden you with that? Because I find as you go on in math that if you do this and grasp that concept and do that shortcut, if you will, people tend to make less mistakes than if they go through all of this. I don't know why, it just happens, but there it is. Take it for what it's worth. Like I say, if you're like, I'm not really ready for that, that's fine. Another day will come. Okay. Let's see here. I want to do this one. Negative the absolute value of 7x minus y plus the absolute value of negative 3z, where x equals negative 6, y equals negative 39, and z equals negative 5. Again, anytime we make a substitution and replace a variable with a number, we're going to put parentheses around the replacement. So this is going to become negative the absolute value of 7 times negative 6 minus negative 39. Close it up because that went right there and that went right there, plus the absolute value of negative 3 times negative 5. So first move, make all the substitutions, replace the variables with their arithmetic equivalency. Or you can say arithmetic. That's a real fancy word. My wife would be so proud. Anytime I use a word over 2 syllables, she's like, good job. Okay. I saw that smile. You can't fool me. All right. Now we're going to go inside the absolute value grouping symbols. We're going to do them from left to right. So we're going to do this first one and then the second one. Okay. So let's see here. Inside, I've got multiplication and subtraction. 7 times negative 6. Positive times negative is negative. So that's going to be negative 42. Subtracting a negative is like adding a positive. So that's going to be plus 39. Okay. Still inside that first absolute value grouping symbol, negative 42 plus 39. So we're adding 2 numbers with opposite signs. Which one's more powerful? The negative, right? So we're going to take 42 minus 39, which is 3, but it's going to be negative. Okay. What's the absolute value of negative 3? It's positive 3. So that comes outside of the absolute value bars, and this negative sign outside hits it. So all of this is now negative 3. Now we're going to come back up here. So I've got plus inside the absolute value bars. Negative 3 times negative 5. Negative times negative is positive. The absolute value of 15 is 15. So I've got negative 3 plus 15, which would be 15 minus 3 is 12. Boy, that's one of those ones where you need a coffee break and maybe a lunch in between the time you start and finish it, right? Okay. We all right with that? Let's see here. I think I've tortured you enough for one day. Wouldn't you agree? Nobody's going, oh, give us more, please, Mr. Mayo, give us more. No, okay. All right. So here's the deal. Okay. Those of you that didn't finish 1D, it's been extended, but you're behind. So you're going to have to, because you got to get caught up with that. Okay. Tonight's homework, section objective 1F, the chapter review. Tomorrow, we're going to review. So tomorrow during class, I'm going to answer questions that you have anything to do with this chapter 1 or whatever it's called, objective. I can never remember what the titles of it are for this thing. I'm used to chapters instead of objectives. But anyway, that's what we'll deal with. And then on Friday, there will be no class meeting, no Zoom meeting. If you show up for the Zoom meeting, you'll see a sign that says, no Zoom meeting today, just take your test, okay? And Friday's test is due by 11:59 Friday night. So don't start the test on Friday at 11:40 and then send me an email. I didn't have enough time, okay? Don't do that. All right, enough nagging. I started class by nagging. I ended it by nagging. What a way to go. I'll be back at 1:15 this afternoon with an office hour. Should you have need of me, we'll stop the recording now.